crossbar in an electrical box serves multiple functions. Firstly, it aids in alignment, ensuring the device is properly positioned within the electrical box for a secure and level installation. Secondly, the crossbar offers additional support to the device, particularly when the electrical box is not firmly secured or the device itself is heavy. Thirdly, in metal electrical boxes, the crossbar often provides a grounding path for the device, contributing to electrical safety. Compatibility is another factor. Some manufacturers require the use of a crossbar for their devices, even when using plastic electrical boxes. It's important to recognize that not all manufacturers mandate a crossbar for plastic electrical boxes. Many plastic boxes are designed with built-in mounting tabs that offer sufficient support and alignment. Determining whether a crossbar is needed in a plastic electrical box comes down to following the manufacturer's instructions specific to the device being installed. When the manufacturer's instructions explicitly state to use the screws on the electrical box to attach the crossbar, it is best to consider the crossbar a necessary component for correct installation. It's always a good practice to double-check with the manufacturer to confirm requirements and ensure safe and compliant electrical work. In general, electrical wiring must adhere to the National Electrical Code, or NEC. For example, NEC Section 314.16 covers the number of conductors allowed in outlet, device, and junction boxes, and conduit bodies and fittings. These regulations are in place to prevent overheating and ensure safety. Regarding grounding, NEC Section 250.146 discusses the use of devices relying on device terminals for grounding. It is vital to ensure that any device using the crossbar for grounding purposes is properly grounded according to NEC standards. When working with electrical systems, safety is paramount. Always de-energize the circuit before starting any work. Use appropriate personal protective equipment, including safety glasses and insulated gloves. If you are uncomfortable working with electricity, it is best to consult a qualified electrician. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work. Remember to always refer to the latest edition of the NEC and local electrical codes for the most up-to-date requirements and regulations. Always follow manufacturer instructions. When you refer to the NEC for electrical requirements, understanding the structure and organization of the code is crucial. The NEC is divided into chapters, articles, and sections, each addressing specific aspects of electrical installations. For example, Chapter 3 of the NEC covers wiring methods and materials, while Chapter 4 deals with equipment for general use. Within each chapter, articles provide detailed requirements for specific topics. For instance, Article 310 covers conductors for general wiring, including their ampacity and installation requirements. Sections within each article offer specific rules and guidelines. For example, Section 310.15 provides information on ampacity tables for conductors, while Section 310.16 covers the allowable ampacities of insulated conductors rated up to 2000 volts. To effectively navigate the NEC, it's essential to understand the definitions and terminology used throughout the code. Article 100 provides definitions for commonly used terms, ensuring clarity and consistency in interpretation. For example, the definition of grounded is critical for understanding grounding requirements, while the definition of ampacity is essential for selecting the appropriate size conductors for a given application. When applying the NEC, it's crucial to consider the specific characteristics of the electrical system and the environment in which it will be installed. Factors such as voltage, current, ambient temperature, and location all play a role in determining the appropriate wiring methods, equipment, and installation practices. For example, when installing conductors in a hot environment, it's necessary to direct the ampacity of the conductors to prevent overheating. Similarly, when installing equipment in a wet location, it's essential to use equipment that is specifically designed for wet environments. The NEC provides numerous tables and examples to aid in the application of the code. These tables provide information on conductor ampacity, conduit fill, box fill, and other critical parameters. Examples illustrate how to apply the code in specific situations, helping to clarify complex requirement. For example, Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to 2000 volts, while example D3 in Annex D illustrates how to calculate the voltage drop in a branch circuit. Regular updates and revisions to the NEC reflect changes in technology, safety standards, and industry practices. These updates ensure that the code remains current and effective in addressing the evolving needs of the electrical industry. It's essential to stay informed of these updates and revisions and to incorporate them into electrical installations to ensure compliance and safety. For example, the 2023 edition of the NEC includes new requirements for energy storage systems and electric vehicle charging equipment, reflecting the growing importance of these technologies. Understanding the scope and purpose of each chapter, article, and section is essential for finding the information you need quickly and efficiently. Use the index and table of contents to locate relevant sections based on keywords or topics. Pay attention to the numbering system you use throughout the code, which allows you to navigate to specific sections and subsections. When applying the NEC, it's important to consider any local amendments or modifications that may be in effect. Local jurisdictions often adopt the NEC with modifications to address specific needs or concerns. These amendments can vary significantly from one location to another, so it's essential to consult with local authorities to determine the applicable requirements. For example, some jurisdictions may require additional grounding or bonding measures, while others may have specific restrictions on the types of wiring methods or equipment that can be used. In addition to the NEC, other standards and regulations may apply to electrical installations. These standards can cover a wide range of topics, including product safety, energy efficiency, and environmental protection. For example, under Writers' Laboratories, or all standards provide safety requirements for electrical products, while the National Electrical Manufacturers Association, or NEMA, standards provide performance and testing criteria for electrical equipment. Understanding and complying with these standards is essential for ensuring the safety and reliability of electrical installations. The NEC is a comprehensive and complex document, and it can be challenging to interpret and apply correctly. Seeking guidance from experienced professionals, such as electrical engineers, inspectors, or contractors, can be invaluable in ensuring compliance and safety. These professionals have the knowledge and expertise to navigate the code effectively and to address any questions or concerns that may arise. They can also provide valuable insights into best practices and emerging trends in the electrical industry. Electrical safety is paramount, and it's essential to take precautions to protect yourself and others from electrical hazards. Always de-energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. Remember, electricity is a powerful force, and it should be treated with respect. Crossbars in electrical boxes, while seemingly simple components, play a vital role in ensuring the safety and reliability of electrical systems. They provide alignment, support, grounding, and compatibility, contributing to the overall integrity of the electrical installation. Understanding the purpose and function of crossbars, as well as the relevant requirements of the NEC and other standards, is essential for electrical professionals and DIY enthusiasts alike. By following best practices and seeking guidance from experienced professionals, you can ensure that your electrical work is safe, compliant, and effective. Grounding is a critical aspect of electrical safety, and it's essential to understand the principles and practices involved. Grounding provides a low impedance path for fault current to flow back to the source, allowing protective devices such as circuit breakers to trip and clear the fault. This helps to prevent electrical shock hazards and equipment damage. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods of connecting to ground, and the location of grounding electrodes. Understanding these requirements is essential for ensuring that electrical systems are properly grounded and safe. Bonding is another important aspect of electrical safety, and it's often used in conjunction with grounding. Bonding involves connecting all metal parts of an electrical system together to create a continuous electrical path. This helps to equalize the voltage potential between different metal parts, reducing the risk of electrical shock. The NEC provides requirements for bonding electrical systems, including the size and type of bonding conductors, the methods of connecting to bond, and the location of bonding jumpers. Understanding these requirements is essential for ensuring that electrical systems are properly bonded and safe. Overcurrent protection is essential for protecting electrical circuits and equipment from damage caused by excessive current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. This helps to prevent overheating, fire, and equipment damage. The NEC provides requirements for overcurrent protection, including the size and type of overcurrent protection devices, the methods of installation, and the coordination of overcurrent protection devices. Understanding these requirements is essential for ensuring that electrical circuits and equipment are properly protected. Short circuit protection is specifically designed to protect electrical circuits and equipment from the high levels of current that can occur during a short circuit. A short circuit is an unintentional connection between two or more conductors that have a voltage difference. This can result in a sudden and dramatic increase in current, which can damage equipment and cause fire. Short circuit protection devices such as instantaneous trip circuit breakers and current limiting fuses are designed to interrupt the flow of current very quickly during a short circuit. This helps to minimize damage and prevent fire. The NEC provides requirements for short circuit protection, including the selection and installation of short circuit protection devices. Understanding these requirements is essential for ensuring that electrical circuits and equipment are properly protected from short circuits. Surge protection is designed to protect electrical equipment from voltage surges, which are brief but intense spikes in voltage. Voltage surges can be caused by lightning strikes, power grid switching, or the operation of heavy equipment. These surges can damage sensitive electronic equipment, such as computers, televisions, and appliances. Surge protection devices, such as surge suppressors, are designed to divert excess voltage away from sensitive equipment, protecting it from damage. The NEC provides requirements for surge protection, including the selection and installation of surge protection devices. Understanding these requirements is essential for ensuring that electrical equipment is properly protected from voltage surges. Arc fault circuit interrupters, or ARCs, are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. An arc fault is an unintentional electrical discharge that occurs when current flows through an unintended path. Arc faults can be caused by damaged wiring, loose connections, or insulation breakdown. ARCs are designed to detect arc faults and interrupt the flow of current, preventing fires. The NEC requires ARCs in many locations, including bedrooms, living rooms, and dining rooms. Understanding the requirements for ARCs is essential for ensuring that homes are properly protected from arc fault fires. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which are dangerous electrical conditions that can cause electrical shock. A ground fault is an unintentional electrical connection between a hot conductor and ground. This can result in current flowing through a person's body if they come into contact with the ground. GFCIs are designed to detect ground faults and interrupt the flow of current, preventing electrical shock. The NEC requires GFCIs in many locations, including bathrooms, kitchens, and outdoor areas. Understanding the requirements for GFCIs is essential for ensuring that people are protected from electrical shock. Electrical panels, also known as load centers or breaker boxes, are the heart of an electrical system. They distribute electricity to different circuits throughout a building. The electrical panels contain circuit breakers or fuses, which protect each circuit from overcurrents. The NEC provides requirements for electrical panels, including their location, installation, and wiring. Understanding these requirements is essential for ensuring that electrical panels are safe and reliable. Conduits are used to protect electrical wires and cables from damage. Conduits are available in a variety of materials, including metal, plastic, and flexible. The NEC provides requirements for conduits, including their type, size, and installation. Understanding these requirements is essential for ensuring that electrical wires and cables are properly protected. Wiring methods refer to the different ways that electrical wires and cables can be installed. Common wiring methods include conduit wiring, cable wiring, and surface wiring. The NEC provides requirements for wiring methods, including the type of wire or cable to use, the methods of support, and the spacing between wires and cables. Understanding these requirements is essential for ensuring that electrical wiring is installed safely and correctly. Electrical boxes are used to enclose electrical connections and devices. Electrical boxes are available in a variety of sizes and shapes. The NEC provides requirements for electrical boxes, including their type, size, and installation. Understanding these requirements is essential for ensuring that electrical connections and devices are properly enclosed and protected.